Hi guys, I hope everyone is staying safe. Please stay home and stay safe. Okay, so in this Corona situation, it's really important for all of us to stay home, maintain social distancing to stay safe. So in this situation, the ESVC has taken up an initiative to conduct 3-day webinar on EV design. Today's day 3 session will be on energy management system and electric safety. And my name is Sai Pranit Reddy. I'm an engineer at KPT Technologies, and I have attended ESVC 16 and 15. Speaking about the contents, Speaking about the content about today's program, today's webinar, we'll be covering the electric vehicle overview and key component selection as motor, battery, and solar cells. Alongside, we'll also be covering the few rounds that are involved in ESVC that are autonomous and solar round, also about the safety of an electric vehicle. Okay, so going ahead, the links for today's assessment will be sent to all the registered people on the registered mail IDs. And for someone who is not registered yet and still are interested, you can go to the video description and register in the link provided below. Okay. So, guys, speaking about today's topic, we'll give an overview of an electric vehicle. I mean, the main components that are involved in the electric vehicle, and the key concepts that we have to consider, like what, like how do we select our motor? What are the major factors that come into play? Obviously, I don't. It won't be like don't select don't select any component based on single parameter, right? The multiple parameters that come into play, and will prioritize the parameters which we give important to, or the things which are very important to us, and then we'll finalize on the components and work on the design of it. In the same way, I'll not help you, and I'll not be selecting a motor for you. I'll tell it in a very very objective point of view. I will not go in depth about which motor you should use or which battery suggestion. No, I'll just give you an overview. What are the factors that we generally consider before selecting one particular component? And it's up to you. You go through the specification sheets, understand it, and come to a conclusion. Okay, fine. Now, giving an overview. So this is an overview of an electric solar vehicle. Like it starts with our source, which is battery, and then followed by few kill switches. And for solar vehicle, we'll be having an solar panels and an MPPT together. In case you're only interested in electric vehicle, you can please ignore this MPPT and solar panels part. Everything else will be same. So it's about a source in the starting. That will be our battery followed by kill switches, and also this MPPTs. Later comes our controller. Even before our motor, it's important we have our controller, and this controller will take inputs from throttle and run the motor, like the motor's direction and all these, and speed, direction and speed of the motor are controlled by the input given from throttle. Okay, so we'll start, and this is like this basic overview of what are the components that are involved in electric vehicle. And going ahead, we'll be focusing on the key components, like let it be motor, battery, MPPT, and solar cells. Okay, so starting with motor selection. So before we go ahead and buy some motor, it's very important to us to decide on parameters such as what would be the final weight of my car, I mean approximate weight, and what is the top speed I'm assuming, and the number of laps I want to run with this car, and what is my speed, torque, and all these requirements. So we had to get a rough idea of these parameters in the first. Then again, I mean, not just those, and all these parameters like the gross weight of the vehicle, wheel size, resistance, all these things, area of the vehicle. So basing on all these factors, we'll decide on our motor capacity, motor power. Once we have decided on the power, the capacity of the motor with which we'll be going with, then comes our very next question: what type of motor will be going with? Is it a DC motor or an AC motor? So before we go into specs, or like advantage and disadvantage of AC and DC motors, in ESVC 2021, or like they have given us the freedom to use any motor. You can use either DC or AC motor. Okay, they didn't give any this rule on the maximum capacity of motor also. So speaking about the motors, as we know, there are two main types of two motors, that is either AC or DC. Everything comes with its own advantage and disadvantage. So in DC motors, the like we don't like in DC motor directly the power coming from the battery, that is, which is DC source, will be used in the will be used, and a motor controller. Motor controller is as we are shown in the previous slide. A motor controller is used to control the motor speed and direction. And one thing is the we have and the thing about DC motor sets, they are a bit less expensive, and also it produces high torques at low RPM. That being an advantage, and the other point of this is DC's torque considerably decreases at high RPM. This is one, we can call it a setback of DC motors. Though they are cheap, though we don't need other extra circuitry as inverter to run the DC motor. One major issue is like we don't get really high torque at high RPMs. But consider if your weight of your motor is not like, I mean, if the weight of your car is not so much, you don't need very high torque requirements. You can still go with DC motor. Coming to AC, as we I'm going to I'm always going to compare everything to Tesla car, because I'm being a big fan of Tesla. So one thing is Tesla uses AC motors. I mean, though AC motors are expensive, they produce good torque. And the one major advantage of AC over DC is they produce good torque, like almost equal torque at all RPM rates, and their RPM is also much higher than what DC can produce. And one issue it has is like the normal torque, like it produces equal torque in the low and high RPMs, right? So this low torque issue of AC uh, is solved by Tesla by using high power motor. And also one advantage of using an AC is this in AC motors we can employ regenerative braking. Even in Tesla, we have this regenerative braking. So that the Tesla, but in DC, we can't implement a regenerative braking system because like DC motors generally don't support it. But whereas in AC, even Tesla has already implemented it. We can it's very easy to implement regenerative braking. Braking is nothing but just storing the power that we generally would have lost while braking. Okay, and one more thing in AC motors is AC motors, you don't generally this inverter, which is inverter, which we use to change the power from DC to AC, convert the power from DC to AC. The same inverter can act as a controller. I mean, it can control the direction and speed of the AC motor we are using. So inverter acts as kind of a motor controller in case of AC motors. Okay. Yeah, and once let's assume we had decided on DC or AC, and in DC motors there's further segregation. Like there are two types of DC motors again, which are breast DC motors and breastless DC motors. Uh, One thing in general is most of the cars these days go with brushless DC motors. This is kind of very famous, and this is kind of very famous, or typically most of the cars, the electric vehicles in India or even WSC go with brushless DC motors because of its lower cost and its high efficiency, and because of the absence of brushes, which would have been a major setback for DC motors. So and also the higher torque ratio at lower RPM. Like considering all these things, most of the EVs these days will go with are generally going with brushless DC motors. And also this maintenance of DC motors is very less. The brushless DC motors, which are also called as BLDC motors, is very less. And let's assume a case where we have chosen BLDC motor. Then comes a major part, that is motor controller. Motor controller is like we can call it like brain of the motor. So this will be you can assemble this motor controller. We can connect this motor controller with motor. This will basically in case of BLDC motor, it controls the switchings. which is nothing but which indirectly controls the speed of the motor, and also changing the polarity. We can even change the direction of the motor. In simple terms, we can using a motor controller that are just attached to a throttle and reverse switch. We can control the direction as well as the speed of the motor. But without motor controller, it's almost impossible to run a BLDC motor. Okay, and ideally the input for this motor controller will be a throttle and a reverse switch. And like as we are done with the like as we are done with the motor controller and the important parameters that come into play while choosing motors and motor controllers, we'll go ahead and start with battery and BMS selections. So though you are done with uh, once you're done with this motor controller, the main thing comes, the main factor, that is the source, the power source, which is nothing but battery. And BMS is something like it maintains the battery pack, which like battery management system, which will maintain the like it employs multiple functionalities to ensure the safety and proper functionality of a battery pack. So going ahead with battery. So uh, before you select your battery, it's very important you know the motor that you are using. I mean the motor and its motor's requirement, and the amount of time you want to run your car, which is nothing but endurance. So these parameters are really important before choosing a battery, because these are like the key factors that define your battery's capacity. And to give a glimpse of to say about the battery types that are allowed in ESVC, these four kinds of battery chemistries are allowed in ESVC. So I would be as it's not I would go with lithium ion battery pack. Let's assume I'll just explain about the components that will be the factors and the components that will be involved in working with lithium ion battery pack. So, and these are the restrictions that are given by ESVC for selecting a battery pack, like maximum energy in different classes and also the nominal allowed voltage. And to speak about the batteries used by World Solar Challenge team, their capacities vary somewhere between 6 to 30 kilowatt per hour. And this we can relate this to this because the varying number of seats, like a few cars come with a capacity of 2 people. They might go, or 1 or 2 persons, that they might go with 6 or 10 kilowatt hour battery. But few other cars come with the capacity of 4 or 5 people. So then they might employ some 30 kilowatt or 28 kilowatt hour batteries. So it totally depends on their design. And also one more thing while choosing a battery pack is, the higher your battery capacity, though you will be you can run longer with your larger battery packs, it will also add weight to your car. So it's suggested you go with an optimal range. Like it shouldn't add a lot of weight to your car. At the same time, it should be sufficient. So it's upon us to how to optimally choose a battery capacity. Okay, and these are major considerations before going and selecting a battery. So first thing is operating voltage. You have to check you have to consider the operating voltage of the motor. I mean all your components before you go select a battery. Let's assume I have a motor that runs at 48 volts. So you need to select a battery which is in that range, like 48 volt. Okay, and size and energy density. You have to consider the weight that is going to this battery is going to add to your car, and also the space consideration. Is your car can you provide enough space for your battery, and also operating temperature. See, you have we will be knowing beforehand where our event might be held, under what temperature it will, what will be the temperature variation there in that particular area will be running our car. So you have to be sure that our battery runs in the particular temperature. Only then we can only then we can go ahead and choose our battery. Then comes the capacity, charge and discharge rate. The charge and discharge rates, which is I'll be explaining in the further slides. Then again, the battery chemistry, which is lithium ion and lithium polymer. All these things that again comes like lithium polymer comes with its own setbacks and advantages. The same with lithium ion also. And next thing is the cost and availability, which would obviously change with every team, which will change, which is in exceptionally with every single team. Like few can afford, few can't afford that sort of batteries. So it's again up to your decision, is that particular battery chemistry with that particular specification available for you or not. Basing on that, we'll go ahead and select our battery. And the next thing is shelf life. So shelf life is nothing but how long can your battery withhold that power. Like let us say if you take some battery and charge it for 100%, how longer, like how many days or how many years or how many months would your battery restore that power? Few batteries, few battery chemistries would lose like 20% and come to 80% of the battery capacity after a day or after a week. So you have to ensure your shelf life is good enough. And let us consider let us consider and do some calculations for lithium ion battery pack. So the voltage, as I said again, the lithium ion battery pack is nothing but a combination of n number of cells that are included in the battery pack. Using these cells, we kind of arrange them in series and parallel combination of these two packs, and make sure and try to get the required voltage and power and current requirements. And then speaking about the C rating of a cell, so C rating of a cell is nothing but the amount it can discharge and charge at any given point of time. Let's assume I'm having a battery pack with 100 amperes, battery pack of 100 ampere hour. And in case the cells in that battery pack, all of the cells in that battery pack have a C rating of 0.5, which means I can produce only 50 ampere hour at a time. I can't produce more than that. And the same will be applying for my charging also. Even while charging, the C rate comes into picture. So all these factors comes into play. This is a simple scenario. Like if you, as long as we'll be connecting them parallelly, my voltage will remain same, but the current capacity goes on increase. So it's upon us, it's upon your particular team's requirement and the voltage and current requirement. We do the series, we take the help of this series and parallel combination, and make a perfect battery for our application. And then these are the few cases where damage might occur to our battery pack. Like considering lithium and battery pack, the external short or mechanical damage or excessive heat or through undesired charge and discharge cycles, our battery pack might get damaged. So we had to make sure we had to avoid them by using proper fuses and age restriction of the cells, which is suggested by the manufacturer. And also we should avoid the over aging of the cells. So this basically ensures our battery is efficient, and also it increases its life cycle of our batteries. And also it's very important in ensuring the safety. And coming with under types of issues that our lithium ion batteries might face is overcharge and undercharge scenarios. So in case of improper BMS, or improper BMS calculations, we might damage ourselves due to overcharging or undercharging of them. So basically, let's basically explain what happens is, if you consider a cell, it has some preset values. It should not be charged about particular amount, and it should not go below particular amount. So as long as you maintain your charge and discharge cycles in that range, your cell will work perfectly and would go for longer duration. It will have a longer life expectancy. But in case we don't follow the rules that are laid by the manufacturer, which are mentioned it's in specification sheet, we don't know. I mean, like the battery might get permanently damaged, or we might lose its efficiency, or that there are chances that your battery is totally damaged. So all of this will be a result of not following the charge and discharge cycles that are suggested by the manufacturer. So we had to take those inputs from the manufacturer and do some calculations on them and make sure our BMS falls in that operation range. Okay. So next, moving on to battery management system. So BMS, as we are speaking from that time, BMS is something plays a very key role in safety and operation of the battery packs, and this also helps in extending the battery life. So what are the functionalities that are supported by BMS? First one being state of charge. State of charge helps in managing charging, discharging. Basically, after by knowing SOC only, which is state of charge only, we can manage the charging and discharging rates of a battery. So this can be done with the knowing by measuring the way we can measure our SOC state of charge is by direct measurement or Coulomb counting or combination of both these methods. We can use any type of we can use any one of them separately or use a combination of both to measure the SOC. And going which also this SOC also gives you the charge, like the percent of battery remaining in the battery pack, the percent of the power remaining in the battery pack. Then going ahead with cell balancing, this is another functionality that is provided by BMS. This so that why the cells like obviously in our battery pack there'll be multiple cells, right? So considering Tesla, it has around 4,000 cells in its battery pack, and it might vary. It might go over until 4, 6,000, 3,000. It would vary from car to car because they are professional cars and they have high requirement. They have some 4,000 cells. We might have around 2,000 cells or 1,000 cells. That depends again on us. So in these 1,000 cells, we are not sure, like due to manufacturing process or due to use of old cells or due to many other factors, there might be some voltage differences between the cells. So if we so without cell balancing, the weaker cells which have less voltage, the chances that they are permanently damaged or fails. So to avoid this problem, BMS uses cell balancing and compensates for this low efficient cells. Okay, so this without this the functionality of cell balancing from BMS helps avoid the failure of less efficient cells and make sure battery pack runs for a longer duration. And second comes the charging control. The charging control is again, this uses SOC obviously as mentioned previously, and the charging of a battery pack through BMS is generally a two-stage process. So what happens is, for the first, like we will consider this graph. In this given graph, we are only considering like after 20 or 30% of the battery power, because in general, you are not supposed to go discharge your battery less than 20%. So let's assume this is our 20% mark, and we charge from 20 to 80%. So once from the if our battery goes to zero, it's almost damaged. So we'll avoid going to zero and we'll start from charging it at 20%. So in this 20% to from 20% to some maybe around 75 or 80%, we will go with constant current. So what happens is, in this constant current, the voltage will be very less. Like in this 20% range, the voltage of the battery will be very less, but it increases over time. So by the time we reach as 80%, the battery voltage would be constant until end 80 to 100%. So what we do is, the first half of the cycle will provide constant current to it, and as soon as our voltage reaches a maximum stage, we'll try to charge it at constant voltage and keep decreasing the current that is provided to the battery pack. In this process, we can do a very fast and very efficient charging of the battery pack without damaging the battery pack. Okay, so and coming back to discharging control, so the BMS plays a key role even while discharging of the battery pack. So what happens is, let's assume I have voltage of like if we keep on decreasing, if we keep on using the battery, this is how the voltage curve looks like. So, and on this note, I'll also mention you Measuring the battery capacity using voltage is very poor process. So you don't know, here at 80% you'll have around 3.75, and even at 20% you'll be having approximately 3.75 volt. So this is not a reliable and an efficient method to calculate the battery capacity. That's why it's really suggested to use the SOC to measure the exact battery percentage. Okay. And one more thing, one major thing during this charging and discharging of BMS is of the battery pack is BMS make sure no cell is charged above the maximum and discharged below the maximum rate. This is one major advantage of BMS. So by this we are done with how do we select our battery, and how do we provide our BMS calculations. So all these are done. Now going ahead with MPPT and solar cells. So for any electric vehicle, like solar electric vehicle, it's important we have solar cells, and the solar cells are efficient enough to run the car. So starting with MPPT. So we all know what are solar cells, but what is MPPT? Maximum power point tracking. This MPPT always helps you in optimizing the output. So it for optimizing our output, it can use multiple algorithms like P&O, incremental connection, fractional open circuit voltage, or even few very advanced algorithms are shuffle, frog, leap algorithm. So there are multiple algorithms that we run, which all of them have their own advantages and disadvantages. So it is always suggested you go through you go pick an MPPT, make sure it's in your operational volt. It's in the provided by MPPT is in your range. It's in the operational range, and then you go ahead to search the algorithms that are employed in that particular MPPT, so that you'll be sure if that MPPT will serve your requirement or not. Okay, so here is another classic example of how MPPT comes to use in a solar panel that are installed into your home. This is just an example. So what happens is the solar power coming from MPPT, coming from solar panels, is optimized with your solar panels, and for DC loads, we'll be generally using this directly. You directly give the output from MPPT and use it over DC loads. But in case of AC loads, inverter is required. And the same when excess or low or higher loads can be compensated from battery. Okay, so the solar cells. So for solar cells, again we have to consider many points. So it's like we have to make sure the temperature is low for the better efficiency of solar cells, and also we have to consider the rule book constraints given by ISVC. So like here are ESVC rules for different types of different classes, and the chemistry if you're using, and for using the concentrators and change in and using multiple types of battery solar cell chemistries. It is always suggested that you contact ISIE beforehand. Okay, and also for solar explaining the interaction between solar cells and MPPT, we have to make sure that the output that is coming from the solar cells array, the parallel and series array which we have made, will be in the range of MPPT output, desired output. Like let's assume I'm having 48 volt, I'm expecting a 48 volt, maybe 5 amperes output from my MPPT. We have to arrange my solar array in such a pattern that my solar cells will give my MPPT voltage above 48 volt, like 48 to 52 or 54 volt, and also my power in the range of maybe 3 to 4 volt, the range which we are expecting. And one more advantage of this MPPT is it will make sure always the output coming from solar cells, which is combined with MPPT, falls in the preset voltage. But depending on the solar power and other factors, the current might be reduced, but the voltage remains constant. Let's assume if you try to check the MPPT efficiency in the night time when no sun is there, you might get 48 volt 0.1 ampere or 0.01 amperes. But and it when you keep it in hot sun and when everything is good, it might go until 48 volt and 12 amperes or 13 amperes. So that varies. The current will be varied, but voltage will be kept constant. This is one major advantage of MPPT. And there are many teams which have participated in ESVC have you made their own solar panels. So the advantage of making your own solar panel is you can customize, you can make the best out of the provided space area on your car to give the maximum output, and you can try with the highest efficient cells. And there are many teams which go with highly efficient solar cells. This is one advantage. And also, I mean, it's always good to do something which do something very efficiently, which you already know, right? So teams, most of the teams which have participated ESVC so far, has always, most of them are tried to make their own solar panels. Like they arrange their own solar cells in the pattern that is required by them, and also and make sure they're laminated. And while doing this, if you have any doubts, please contact ISIE regarding if something is not if you don't get something in a rule book, though everything is clearly mentioned in rule book. So as we're done until this what solar we are done with motor selection, motor selection, battery, BMS, motor controllers, and also our solar and MPPT. We'll go ahead with few rounds, innovative rounds that are present in ESVC. So in our ESVC, we have two rounds which are autonomous and solar round, which are new. So I felt that I mean not new, but kind of different. So I felt there's a requirement to explain what exactly these rounds are. So going ahead with autonomous round is kind of showcasing the smartest which is present in your car. Yeah, it helps in providing the it helps in showcasing the level of automation as smartest that you're integrated into your car. And for doing this autonomous round of we need multiple sensors, DAQ and telemetry system and dashboard. So what happens is, if you want like in these days, I'll give you a small example. Like, can you even guess how many sensors that are there in present day car? Okay, the answer would be somewhere around like hundreds, like 100 to 200 or 300 sensors would be on the cars that we are using. Mid range to highest, it would range from 100 to 300 sensors. So what happens is these sensors will make sure for an efficient work of efficient functioning of our electric vehicle or any vehicle to say. And in general, most of the complex systems are generally replaced with a smart sensor and algorithm. Okay. So speaking about the few sensors, I'm not saying we're not telling you to use the exact sensors, but this is just a simple overview of the kind of sensors that will be helpful. So let's assume you're doing it, you're preparing a car, you build the car, you're done with the calculations, you bought the components, you're running everything fine. But in case you want to monitor the current and the voltage that is going on through your from a battery to motor controller, and how much current is drawn by your motor. So for doing all these things, not all of the motor controllers and BMS will provide you their pre-sensed data. So it's your role. If you need some current and voltage input, voltage readings and temperature and smoke for safety. So what happens is, if someone asks me what is the use of current sensor in an electric vehicle, I would say was go and keep it after your battery and before your motor controller, so that you'll be able to monitor how much current is being drawn by your motor. So let's assume you'll tell will already tell our driver, see, this is the current range, which current range for that can be consumed by our car. Let's assume, they're just hypothetical values. So let's assume some zero point 0.5 amperes or 1 ampere should be drawn by your motor in ideal conditions, and maybe 1 or 2 or 3 amperes in case you're climbing a hill, or in case you're giving a sudden acceleration, sudden throttle. So all these scenarios will explain the driver. And in case he sees an abnormality, like if car is functioning very normal speed and your battery is drawing like 10 amperes or 5 amperes, in these situations, in case of overdraw or underdraw of current, we can, by knowing the exact current that is being drawn by the motor, we can always use this data to avoid many risks involved, like maybe in sensing the high power consumption of motor beforehand can help us uh, help us stop the car and debug the issue and make sure everything is smooth. And voltage sensor is again employed in the circuitry where you feel okay, something might go wrong, the voltage might fall down. So in those cases, it's suggested we use voltage sensor and make sure everything is normal, and we can give indication to the driver if something is abnormal, or if you have implemented telemetry, you can give it the same alarm to all the teammates. So coming down, so first thing is we sense beforehand if current and voltage are in place, right? And then second comes the secondary. This is the first primary safety. You make sure everything in the circuit is fine. Then what we do is we go ahead and keep an eye on temperature and smoke. So let's assume your this you keep will keep our temperature sensor and on our motor, like on our motor controller. Ideally our motor controller temperature maybe should not raise above 60 degrees or maybe something, but in case it goes above that or it's overheating, we can use with the help of the sensor data, we can always stop we can always stop the injuries or dangers that might be present. And even the smoke sensor, in case there is some smoke coming out of some component of the car, and being a huge car, driver may not be able to see every component, so the smoke sensor can sense it beforehand and give it the data to you. Using that, you can stop all the you can sense the fire or smoke in the very early stage and make the take adequate steps. These are like I would say, if someone asks me, these four are mainly for safety of the car. Then comes the smartness like ultrasonic, GPS, and gyro. So what is an ultrasonic sensor? You can use any proximity sensor. Ultrasonic is just an example I have provided. So using ultrasonic sensor, you can avoid collisions in, for a rear or front collision. You can always, this is generally employed in our present day cars also in parking assistance. You can use the same sensor, I mean similar technology, and implement it for avoiding collisions in our car, in our solar cars. And then comes with GPS and gyro. We all are very aware about what is GPS. And using this GPS module, one advantage is we can locate our car's position, and using the GPS data, we can calculate the number of rounds that are being covered by our car, and also gyro sensor to give 9-degree IMU of the car. So giving an overview of the sensor, all of these sensors can help us monitoring the real-time data that is coming through the car. And also, if all these values are stored somewhere, you can further analyze the values and draw some conclusions from the values, so that you can improvise the betterment of the car for the upcoming versions. So if you can by making the best use of the sensors, it's always suggested we can always make a better car and make sure we are all safe. Then coming to the PCB boards. So ESVC always recommends use of PCB boards to avoid confusion. So what happens is when you have numerous wires that are running through, and if you don't have a proper circuitry, we might end up shorting few components. That's a huge loss for the teams after doing a lot of hard work. So we always suggest you to go with PCB boards. Make sure all your connections are perfect and check them on PC boards beforehand, so that it will avoid any further confusions. And now, what is data acquisition? So we have make sure we have kept all our sensors, we have made sure they are working, kept them all on PCB. Now the next step is, like, let us say the smoke sensor one will be placed maybe in the front of the car, another temperature sensor maybe in the rear part of the car. So the data will be generated at different points in the car, but our we can only use the data if it comes to dashboard, if it's only visible to the driver. So the important part is getting the data from all corners of the car and getting it and showing it on the display or dashboard. So for this, we need data acquisition system. So for getting the data, we need some communication protocols to transfer the data. If you try to transfer the data using normal communication protocols as I2C or all these SPA or UART, all these kind of protocols, this won't work. This will fail because of the lot of noise that is involved in automobile environment. So it is suggest we go with some automobile based communication protocol, which are nothing but CAN and LIN. The CAN and CAN is control area network, which will provide you the speed of 1 Mbps to 10 Mbps based on the type of CAN network you're going ahead with. And also LIN provides a bit lower speed, but still one advantage of LIN is it will reduce the number of wires. It's just single wire protocol. While a CAN is two wire protocol. You just need two wires to run this protocol, no matter how many sensors, the number of sensors, the amount of data you have. Just using two wires, you can transfer a lot of data from all the corners of the car. That is one major advantage. And why? And if someone asks what is the advantage of using communication protocols, I would say these protocols are very flexible and robust for automobile environment, and also they're immune to the noise. They're built in a way that we are immune for this kind of noise, and they're very fast considering the length, the distance that is involved. Okay. So we have collected data from the sensor. We have used PCBs to organize the circuit. We have collected all the data from all corners of the car using DAQ. Then what is the next step? If you want to limit yourself by just showing it to the driver, that is fine. But if you want to go ahead and show it to all your team members also, or show the data, make the data available remotely also, the next step will be telemetry. It's like tele transmission of the data from car to for this transmission you can use IoT, RF, you can use XPVs, again some part of RS. So all these you can this with this one advantage is all team members, like considering a typical ESVC scenario, so all the team members will be aware about the functioning of the car, what is the speed of the car, if the car health is fine or not, or and like what is the exact scenario of the car vehicle. So all the team members will get to know it. This is one major advantage of telemetry. Okay. And this and in the upcoming ESVC 2021, ESVC 3000, which is ESVC 3000, the plan is to have a 1600-kilometer rally of all the race of the all the ESVC cars that are involved. So in this one, make sure all your systems and sensor you can make use of all the systems and sensors to make your work easier. I mean, maybe in 1 kilometer or 2 kilometer track, running behind the car or seeing where it is will be fine. But in 1600 kilometers track, it will be literally impossible to track where your car is and like what is the health of the car. So it's suggested you. It's not a rule, but it's suggested you have some telemetry and data acquisition systems to know the health of the car, to know and get to know any problems if present in the car beforehand and try to solve them. Okay. And then dashboard. So whatever the data you collected through CAN will be shown on dashboard, and also according to ESVC there's few mandatory uh, things that have to be present on the dashboard. That is start button, that should be present on the dashboard, speedometer which shows the driver the current speed of the car, and battery level and health indicator. It's very important driver knows the battery level and also health, like what is the health of the battery, if it's damaged or if is there some issue with the battery. So it's always suggested it's mandatory the battery level and health are indicated on the dashboard. Then again the reverse switch, if the car wants to go like change the direction or go back, it's mandatory the driver has this in control, the reverse switch in his reach on the dashboard. And then comes the skill switch. Skill switch is again mainly for the safety purpose, and driver, it should be very handy for the driver, and also the hazard light in case something goes wrong. And further scope, if someone asks me like and one more thing about this further scope is in fully you're free to make fully autonomous vehicles. Like the car, you can try to make run the car in fully autonomous mode for any for a particular distance or particular period. That will be evaluated by ESVC judges, and you'll be rewarded points for that. And then comes further scope. If someone is not, like, if you have implemented everything previously and you want to go ahead and improvise your car even further, you can go with regenerative braking. So what happens is, to speak about regenerative braking, this was implemented by Tesla. This is very easy to implement in most of the AC based cars. So you'll be simply using the power that would have been lost generally while braking to recharge your battery, and so that you can use it later. So this is one advantage of using regenerative braking. In general, if regenerative braking is used, you can almost save get back 12% of 12 or more percent of battery, that is power that is being spent. And this 12 varies, like you're driving pattern and on many factors. But one thing is, doing these systems will help you get back the power and make sure you can run about the 1600 kilometers effortlessly. And also booster circuits. So one more thing is, so most in almost all the in most of the cases, and like always in an electric vehicle, we need there's a requirement for high torque in the starting of the car. So this high torque, during this high torque, like which is directly related to the high current, your battery might not always be in a position to provide that enough torque. So I mean, we do all our calculation to provide high torque, but in case high current, but in case battery is not in a position to give that high current, booster circuit, which can be used, which with the help of some super caps or super capacitors, will make sure you always get the enough boosting circuit, enough current in the starting of the car. Okay, and one more round one of the famous rounds in ESVC is solar performance round. So it's just testing the car's solar electric vehicles capability to run only on based of the solar power. So what happens in this round is, your battery will be totally electrically disconnected from all this other circuitry, and your car should only be running on solar power that has been generated. So in for at least for this one, it's very important you have enough, your solar panel cells and your MPPT is optimized to give you the best results. Okay, and one more thing about using solar cells is, make sure you follow, you maintain your cells properly. I mean, no, you try to avoid the dust on solar cells, you try to keep them at lower temperatures. All this will help for the higher efficiency of solar cells. Okay, and coming to safety and the other systems. So, what about the first thing that comes into our mind when speaking about electric safety, DC safety, is insulation. We have to make sure double insulation is present on all the cars, on all the high voltage wires, and make sure you maintain enough spacing between low and high voltage wires. And one more thing is rated wiring and rated contacts. So you have to make sure your particular wire is uh, capable of handling that particular voltage or current requirements. So I'll give you an example in one of the events I've attended. What happens is, one team has came up with an exceptionally good design, and the car was really good. But the one thing they made a mistake was, they use low rated wire, like very thin wire for a high voltage requirement, because of which the wire burned, and they were, I mean, the half of their car was burnt, and they finally ended up being disqualified. So to avoid these unexpected situations, you make sure all your wires and contacts are rated of that particular voltage and current. Okay, and then coming to battery safety. So your battery packs should be IP67 certified. This is also mentioned in the rule book, and it's for your own safety. And second one is battery shielding and insulation. our battery should be properly shielded and insulated from all from a full car, and make sure your battery is rigidly mounted, because while running while the car is running, it's important your battery is not shaking or vibrating. And then in case if you feel there's a need, you're free to use cooling fans or and one more thing, speaking about Tesla's battery. Tesla has used as spaced has made sure a coolant is running between their batteries to ensure the battery always maintains its temperature, will not goes about particular temperature. So you can use any of the smart methods to avoid overheating of the battery, but again make sure it follows in line with the ESVC rules, and also please contact ESVC in case you are trying something new apart from Rulebook. Okay. And in case any team is having a spare battery, make sure its dimensions, specification, everything are exactly similar to the first battery. It's very important. And battery's position. It's make sure battery is positioned safely and it follows the rulebook constraints. And one more thing about the battery is it should always be accessible, and in case of any scenario, it should be easy to detach. Okay. And mandatory systems on dashboard, again it's mandatory. You have a horn, brake light which should be visible, horn that is audible, and brake light which is visible from a far away distance of a rear car, and also battery level indicator, a proper battery level indicator showing the SOC, not just the voltage or power, it's not accepted. And the side indicators in case you're taking turns, and also a hazard light. These are the mandatory systems. And kill switch and BOT. So kill switch and BOT are supposed to be placed right after the battery and before all of the circuit. It should be placed in such a way that if any of the kill switch or or brake travels is used, you should all of the power supply to all your circuitry from battery should be shut down. This is the main point of keeping kill switch and BOT. So kill switches are something that are accessible, that should be very accessible, while brake over travel will be right behind the brake, so that it in case of over travel of the brake due to leak of brake fluids, in this unexpected scenario, the brake over travel will cut the power supply to all the other circuit and keeps the car safe. And so again, I would like to inform you all that a link will be mailed to your registered IDs for the assessment of this today's webinar. And in case someone is not registered and interested, you can always go to the registration link that is given below in the description of this video, and you can register. So people who are registered today also will get a link for the assessment by today end of the day, today midnight. Okay. So please, and one more thing is, teams who are interested in ESVC uh, can, if registered before 30th April, will get a 25% discount. Okay, guys, thank you for your session. Thank you for attending this session. Thanks a lot.